But for practice, let's go ahead and do this. Oh, probably shouldn't have.
So it's silver and nitrate.
Right.
Or is it nitrite? I can't remember which one it is.
Yeah, so the 3 is the 8, so nitrate.
So if it's a polyatomic ion, we'll just name it right off.
Perfect.
Yeah.
Mm-hmm. Yeah, so that's another reason why we wouldn't want to do nitrogen trioxide. Mm-hmm. And then the charges on these guys?
Silver, well, I think it would help if I had just memorized. So nitrate has a... I don't know what the charge on nitrate is.
Okay.
Is it a -3 or -2?
It's actually a -1 for nitrate. And silver. So
you could tell that because there's only one silver.
Well, we know that they have to be equal, right? Because there's no subscripts for either of them.
Yeah.
And so regardless of what the charge actually was, let's just say that nitrate did have a charge of -3, even though we know it has a -1 charge. That means that silver would have to be +3, right?
Mm-hmm.
Because there's no coefficient or no subscripts for those guys. But we know that nitrate is a -1, and we also know silver is a +1. So this one was if you knew either of these, you'd be able to get the answer. Does that make sense?
Mm-hmm. I just don't know either one of them. So you can always tell if it's a plus. Where is silver?
So silver is not on the left side of the periodic table with sodium and all those guys, where that first column usually is a +1 and
right.
the next +2. Silver, we just have to memorize that it's a +1. And then if we just move up, so it goes silver diagonally, zinc, and then aluminum.
Yeah.
Right? Or is it silver, aluminum, and then zinc?
No, it's silver, zinc, and aluminum.
Okay, so silver, zinc, and aluminum. Silver has +1, zinc has +2, and aluminum is +3. And that's always the case for those guys.
Oh, that's nice.
Mm-hmm.
Aluminum is +3. Oh, yeah, and then aluminum falls in the +3 column anyway. So what about the column that carbon's in? What charge do they have?
So that one, once you get into the next, I think you guys will probably be doing, they're called redox reactions. And it's just talking about where elements are either lose or gain electrons in the process of the equation. And once you get into that, it'll make a little bit more sense about those charges.
So we just leave them alone for now.
Right. So carbon's charge is really dependent upon whatever it's attached to. Does that make sense?
Mm-hmm.
And so it's not really good to memorize a charge for carbon because it changes all the time based on what compound it's in.
Okay.
Mm-hmm. And so basically after like the second row or second column on either side, I just don't, unless it's, I don't assume the charge unless it's like silver, zinc, or aluminum.
Well, they usually will just have to give it to you then.
They'd give it to you, or other elements in the compound would be ones that you would already know, and then you could just figure it out that way because it would be the remainder of whatever's left over.